this project was to design and build a model rocket to be as efficient and aerodynamic as possible in order to reach the maximum altitude possible while also employing a parachute to ensure a safe voyage for our egg, Herbert. During our design process, we chose to keep our rocket body at the maximum length allowed, 16 inches, in order to disperse the weight of the payload as widely as possible. We also decided to mount our camera inside the body in order to decrease drag.
So how did day one go?
Oh, this is a video.
Yep.
It went pretty decently. I'd say we got a good amount done. I'm proud of us. Yeah, Herbert's home is looking pretty good.
Our next decision regarded fin shape and length. We chose to go with a basic semi-triangular shape with a slight outward curve on the leading edge. We wanted to keep the shape simple and easy to attach. Finally, we chose to make our rocket a candy cane because who doesn't love some Christmas spirit in the middle of October? The graph shown is a plot of thrust of 3 different model rocket engines. As you can see, the A motor had the smallest magnitude of thrust per time versus the D motor, which had the largest. Each motor had an initial spike in thrust before leveling out to a steady burn rate, and the second negative spike in thrust for each motor is the ejection charge. The values of thrust and time before ejection charge are predetermined by the manufacturer.
One arrow, one bus.
The graph shown is a representation of the altitude, shown in magenta, and thrust, shown in green, of our rocket over time. As you can see, the thrust initially increases quickly and then declines over time before having one final spike from the ejection charge. Altitude increases steadily and continues to increase even after the thrust drops off, before finally decreasing at a constant rate. Our rocket experienced an unplanned water landing, so most of the data was irretrievable, but the altimeter managed to beep out an altitude of approximately 750 feet. Our parachute deployment was also a failure, as the parachute detached from the rocket. As for Herbert, he avoided the fate of the frying pan, but he still ended up a bit scrambled.
Probably would be good that we all pay attention during the actual launches, but please don't lose too much focus. We really need to keep moving to get the rest of the trip. Watch things for the next 10 minutes.
Greatest. We're using the SpaceX patented dog retrieval method. Oh no! So close. Dog retrieval system 101. Attempt 1, failure. We'll have to go back to the drawing board on this one.
In the future, we will focus further on our parachute design, increasing the width of the chute and also increasing the length of the shock cord to decrease the impulse on the string. We also learned that fin symmetry would be beneficial in preventing the spinning and irregular trajectory of our rocket during flight. And finally, that even the best of dogs can't always deliver on results.